Welcome to Martin's Institute of Teaching. In this video we're going to solve for the general solution of the given differential equations. So I'm just going to go ahead and jump in and start solving these. If anything doesn't really make sense, I really recommend, I made a video prior to this one where it explains how you go step by step to get everything. And so if you have any questions, I recommend you go back and check that video out. So let's jump ahead and solve these two problems. So we're going to solve this first one right here, which is y prime plus 1 over t times y is equal to 3 cosine 2t. So the first thing we want to do is solve for the integrating factor, and the integrating factor, you're going to get it over this part of the equation. So the integrating factor, by the way, this part also includes that plus sign, or if this is a negative sign, it's going to be this is going to be p of x. So the integrating factor is going to be equal to e to the integral of pt dt. And here pt is just going to be equal to, it's going to be equal to 1 over t. So we're going to sub 1 over t in for pt. So this is going to be equal to e the integral of 1 over t dt. Once you integrate this, you're going to get an integrating factor of ln of t. By the way, when you're working with the integrating factor, you do not put the plus c here. So, okay. So here the e and the natural log, they're going to cancel. And you're just going to be left with an integrating factor, which is equal to t. And now we want to multiply the integrating factor into every component of our differential equation. So you're going to have t times y prime plus t times 1 over t, so these are all just going to cancel, times y is equal to t times 3 cosine 2t. So now we want to take, after we do this, after you multiply everything by the integrating factor, you're going to integrate both sides of the equation. If you integrate this side, what you're going to find that you're always going to get is basically the integrating factor times y. So this would be t times y. So if you take the derivative of this, you're going to use the product rule to take the derivative of it. The first thing you're going to do is, if you take this derivative with respect to y, you're going to get t times y prime, which is this part of it. And then if you do it with respect to t, you're going to just get y, which is this part of the equation. Now this side. Now this is, I'm going to rewrite it. So I'm going to take the t and just put it on the outside of the integral, times t times cosine 2t. Now here, you can solve this by a couple ways. You could either do integration by parts, or I think an easier method is to use tabular integration. In the previous video I explained how you do tabular integration, but I'll go over it really quickly. So the way you do that, you're going to get the two components. One is the t, and the other one is the cosine 2t. I'm going to write the t here on the left side, and on the right side I'm going to write cosine 2t. Now, on the left side here, with the t, you're going to take the derivative. And on the right side, you're going to take the integral. So first let's do the left side. So the derivative of t is just 1. And then we're going to do the derivative of 1, which is 0. Next, we're going to take the integral of cosine 2t. The integral of cosine 2t is going to be equal to 1/2 sine 2t. And if you're wondering how I get this, what I'm actually doing is I'm doing u substitution. So I'm going to let u equal 2t, then du is going to be equal to 2 dt. Then I'm going to bring that over, so I'm going to get 1/2 du dt. And I'm just going to put the u, so then I'm going to say the integral of cosine u du, and remember we have the 1/2, so it's going to be 1/2. The integral of cosine of u du is just going to be equal to 1/2 sine u. And that's how I get this. Now, if I take the integral, now if I do this again, if I do the integral of 1/2 sine, remember u is just 2t, so it's going to be 2t again. If I take the integral of this again, I'm going to have to do the u substitution again, which means that I'd have to substitute the u for 2t. And if I take the derivative of the u, I'm going to get du, and if I take the derivative of 2t, I'm just going to get the 2 dt. And so again, I have to bring the 2 over here to get the 1/2. And then I have to just sub these into this part right here. And when I do that, I'm going to get 1/4 the integral of sine u du. And so the integral of sine, you're going to get negative 1/4 cosine 2t. And again, you're not going to put a plus c here. So this is going to be equal to negative 1/4 cosine 2t. And so now that we have this, now what you need to do is you're going to multiply the t times this first entry, and you're going to put a plus on that. The next one you're going to multiply is the 1 into the next entry down here. This is going to be a negative. So let's go ahead and plug that into the equation. So this is going to be t times y is equal to 3. And here's where we're going to enter it in. So the first part is t times 1/2 sine, and this is a plus. So this is going to be t, well actually it's going to be 1/2 t sine 2t. This next part is going to be a negative. So it's going to be negative 1 times negative 1/4 cosine 2t. So after I get this, I'm going to multiply the 3 into both of these. So this is just going to become t times y is equal to 3. Oh, don't forget, since I just integrated, this is going to be, now this is the part where you are going to enter the plus c. That's very important, so don't forget it. So that's going to be on the outside. So now we're going to multiply the 3 into this, into all of this. So you're going to get 3/2 t times sine of 2t. This minus and this minus is going to make it a plus. So it's going to be plus, but don't forget we're multiplying the 3 into it. So it's going to be plus 3/4 cosine 2t plus c. So now once we've gotten to this part, now all that's left is to rearrange the problem. So first thing is we're going to get just this, the left-hand side of the equation in terms of y. So you need to divide this by t, and then you're going to, in order to get rid of the t on this side, you're just going to divide everything over here by t as well. So once you do that, it's going to be divided by t. You're going to divide this by t, and you're going to divide this by t, and you're going to divide the c by t. So we're going to get y of t. Well, actually, I'm not going to write that in there. We're just going to get y is equal to 3/2 sine 2t plus 3/4. Now t, since it's just 1 over t, it could be written as t of negative 1 times cosine 2t, so plus c of t negative 1. And that is your solution. Y is equal to 3/2 sine 2t plus 3/4 times t of negative 1 times cosine 2t plus c of t to the negative 1. And that is the solution to the differential equation. So now let's go on to the next one. Okay, so now we're going to get started on this problem. Okay, so here we have y prime minus y is equal to 2 times t e to the 2t. So the first thing we want to do here is solve for the integrating factor, which it looks like I already did it. So here, this negative is going to be your px. So your p of x is actually equal just to -1. And so that's going to get put into here. So you're going to take the integral of e to the -1 dt, which is just going to be e to the -t. Remember, here we do not insert a plus c. So after that, we're going to multiply everything in this differential equation by the integrating factor. So we're going to get e to the -t times y prime minus e to the -t times y plus, oh wait, not plus, this is equal to e to the -t times 2t e to the 2t. You can barely see that negative sign right there, so let's, there. So now once we do that, you're going to check over here to make sure that, well, first remember that this should be the integrating factor just times y. If you did this correctly, that's what you're going to get. But you're going to need to integrate this side and this side. If you integrate this, you should get this. So if we take the derivative of this, we should get this. And if we take the derivative of this with respect to y, we're going to get y prime times e to the -t, which is what we have here. The next part is if we take the derivative with respect to e to the t, then this is going to be, the derivative of e to the -t is just going to be negative e to the -t times y, which is what we have here. And now here, we need to take the integral of this side. So let's see. Now here we have e to the -t, and then we have an e to the 2t. So that can actually be rewritten. So if we have e to the 2t times e to the -t, that is equivalent of saying e to the 2t minus t, which is just equal to e to the t. So we're going to have the integral of 2t e to the t dt. So here, in order to integrate this, we're going to need to use integration by parts. Or I'm just going to use tabular integration. So again, I'm going to say t and then e to the t. The derivative of t is 1. Taking the derivative again, I'm going to get 0. Here, if I integrate e to the t, I'm just going to get e to the t. If I integrate this again, I'm just going to get e to the t again. Remember, we're going to multiply these two. This is a plus, and we're going to multiply these two. This will be a negative. So this is going to be negative e, oh wait, not negative, sorry. Let's scroll down. So this is going to be e to the -t times y should be equal to, now I'm going to pop this 2 out. So that's going to be 2. Now first is t times e to the t, so this is going to be t times e to the t. The next one's a negative, so it's -1 times e to the t. And don't forget to put the plus c here. Okay, so once we do this, I'm not forgetting anything, right? Don't think so. So okay, so let's go ahead and rewrite this a little bit so it looks a little bit neater. It's going to be e to the -t times y is equal to 2. Now here this is just t e to the t minus e to the t. So I can actually take an e to the t out. So it's going to be t minus 1 e to the t plus c. And here, now I want to get rid of the, oh actually I want to isolate the y. So in order to isolate the y, I'm going to divide by e to the -t. So dividing this by e to the -t, this will cancel. Now I'm going to divide this side by e to the -t. I'm going to divide this by e to the -t. That's going to leave you with y is equal to, oh, and so if I do this, I can flip this. I can rewrite that as e to the t, that's this one, times this guy, which is e to the t again. And the reason this becomes positive is because I'm moving it from the bottom up to the top. And that's going to just be equal to e to the 2t. Because remember, when you have them like this, that actually gets rewritten as e to the t plus t. So these two get added, and you get e to the 2t. So you're going to get 2 t minus 1 e to the 2t plus plus c times e to the t, because I'm flipping this up top. So that flips the sign on there. And this is your general solution to the differential equation. Okay, so I hope these videos made sense. I hope they helped you out, and good luck in your classes. Oh, and if you liked the video, don't forget to click like and subscribe.